Today we'll cover, we'll do review for test 2, and then we will go over 5.2, 5.3. The material I use to review for your test 2 will be from fall 2015 Math 227 test 2 at ELAC College. Now, in case you don't remember how to get my old tests, let me show it to you. Go to my website, carjuno.com, and then click my face or my name, and then on menu, click previous teaching. Then you will see the list of classes I have taught since fall 2007. Now you scroll down to see under ELAC College, and you will see the statistic classes I have taught. So if you want to see fall 2015, is this one here. Fall 2015 under ELAC College, Math 227, Test 2. Then you click that one, you will see some questions that I will go over today. Okay. Now, I will start with question number 3. Question number 1, I skipped that. Maybe, well, I may go over that next week or even the end of today. Question number 1 from that test and question number 7 are binomial distribution. So I will postpone going over that until much later. Question number 2 is a very common question that I ask. If I have time, then I will cover that at the very end of this review. Let's start from number 3, something that we have just learned last week. The following lists the probability distribution of X, the number of typos that appear on a randomly selected page of a newspaper. Now extend this probability distribution to find the mean and standard deviations of the number of typos on a page of newspaper. Now, this is the probability distribution. Okay, what we will do is to extend it. Now, when I give you the probability distribution, I usually don't add them up. You need to add them up yourself. Okay, you need to add them up yourself. Instead, in the last couple of years, I actually hide one of them. Let's say, imagine if I don't put this in. Imagine if I don't tell you probability of X equals to 2, then can you find out yourself? Now, we know it's a probability distribution. Therefore, the total has to be 1, right? The total has to be 1. This has to be 1. And you can use this one to find this. Okay, 1 minus 0.91, 0.05, 0.01, right? The total has to be 1. So I subtract the sum here from 1. That's 0.97. That's 0.03. Okay. So suppose I wipe out that probability X equals to 2. Can you find it out yourself? Yes, because knowing that it is a probability distribution, then the total probability has to be 1. Okay. Now, another thing to mention is sometimes this notation confusing some people. Now, in my recent tests, in my recent lecture, I use only P for probability. Okay, but in higher statistic or higher probability, you may see Px instead, the way it is written here. That's the probability of event X. Okay, now not in the sense of multiplication, but in sense of functional notation. So not P, not as P times X. You see what I mean? No, not as P times X, but P as a function of X. P as a function of X. Okay, so you may see P parenthesis X, you may also see simply P. Now, P times X will not be written that way. P times X will not be written this way. This is P probability of X. P times X, which is our next extension, will be written Px as usual, like that, without parentheses. Okay, now we learned this last week. I would like you to take maybe a couple minutes to extend this table. Okay, you do it and I will do it too. But I hope you kind of like review a little bit what we did last week. Okay, the first extension is px. The second extension is x squared and then px squared. Then you use your calculator to compute this. Or if you can use Excel to do it faster, go ahead. Let me do this first. This is 0.06 and then 0.02. That will give me 0.14. Okay. Now from there, then we know that the mean of random variable x, which also usually said as expectation of random variable x, is the sum of px, in this case 0.14. It is 0.14, is this 0.14. Okay, now I go on with the second extension. X squared, this is 1, this is 4, this is 9, multiplied by the corresponding probability 0.05, 0.12, 0.09. This will be 0.26. Then the variance of x will be the sum of px squared minus the expectation, the sum of px being squared. Okay. Everybody with me, by the way? Yeah, this is 0.2404. But that's not the standard deviation though. The standard deviation is the square root of that. So square root, standard deviation of x is square root of 0.2404. Then I use my calculator to get 0.49031. Okay. Any questions so far? No question. Okay, let me scroll this. I will save it later on. So if you happen to be behind on your notes, and go to the discussion at the end of the day, then you will see my my notes. Okay. Yeah, but if you want me to scroll back, go ahead. Number four. There are 15 identical markers, except in colors. There are 7 black, 5 blues, and 3 red. 3 markers are selected, one at a time, with replacement. Find the probability of selecting any blue markers. So basically, probability of any blue markers means at least one blue markers. Okay. Now, the thing is, this one will be done with replacement. To have at least one, that means 1 minus probability of no blue, right? Which is equal to 1 minus. Now, can you compute the probability of not getting any blue? Don't forget, this is with replacement. Now, so what is the probability that the first one is not a blue? How many not blue? 5 blue, 10 not blue, correct? Okay, so if we grab 3 markers with replacement, okay, and all of them not blue means all of them has to come from this group. Okay, not from this one. Okay, so what is the probability that the first one is blue? The first one is not blue. That will be 10 out of 15, right, times. It is with replacement, so once you get that not blue marker, you put it back, and then you select from that 15 again. The probability that the second one is not blue is 10 over 15 again. And the last one to be not blue is also 10 over 15. Again, that's because it is with replacement such that the probability of getting not blue the first time, the second and the third time are all the same because you put it back. Let me simplify this a little bit. That's 2 over 3 cubed. That's 1 minus 8 over 27. That's 19 over 27. Or of course, feel free to use decimal to do that. Just be careful not to do rounding too early. Okay, now part B. 3 markers are selected, one at a time, without replacement. This time you don't put it back. This time you don't put it back. Then find the probability of getting a red marker first, and then 2 black markers. So what is the probability to get red, and then black, and then black? I wonder if you can try to do it on your own. Okay, and then in part C, it's very, very similar, but this time you want to get 1 red and 2 black, regardless the order. So I wonder if you can see if you can distinguish the difference between part B and part C. So part B, the order matters, okay? While part C, the order doesn't matter. Now let me give you approximately 1 minute for each. Okay, let's start. What is the probability that the first one is red? The first one need to be red is 3 out of 15 times the probability that the next one is black is 7 over 14 because it is without replacement. Okay, and then the third one, black again. So you have only 6 black left out of 13 markers left. Okay, and then from here, either you convert, you write that in fractions or in decimal. Either way is okay. Let's see if this is 1/2, this is 1/5. So that would be 3 out of 65. if I write it in fraction, or you can also, of course, answer that in decimal if you like. 3/65, or in decimal, 0 point something. Okay. Likewise, the one here, if you want to make it in decimal instead, go ahead. If you really want to make it in decimal, then since the beginning, after you write this, then you compute this overall as a decimal right away, instead of like, if you really want to simplify and compute it that way, then just do it in fraction. Okay, but it's up to you. It's your convenience. Okay, just keep in mind that when you write it in decimal, then round it to at least 5 decimal places, unless otherwise told. Now, next, part C. What happens if we don't worry about the order? Well, then we will see it this way. Look at the boxes, right? The categories. We have 7 black, 5 blue, and then 3 red. We need to have 1 red, so you need to choose 1 from here, and then 2 from here. You need a total of 3, and now we have 3 already. It means nothing from here, nothing from blue, right? Nothing from blue. And therefore, this will be, for the red one, 3, choose 1. For the black one is 7, choose 2. And then 5, choose 0. You will see 5, choose 0 is 1, such that if you see in my solution, I don't write it down, then it's fine. Okay. In other words, if you don't write this part here, only this, you write only this, you're okay. You get the same answer, because 5 choose 0 is 1. It won't affect the solution. This is, then you use your calculator. This is 3, this is times 1. What is 15 choose 3? You can use your calculator, but I'm kind of lazy. This is 5. I'm sorry, this is 5 and this is 7. So 35 times 13. 455. So this will be 63 over 455. And then from there, if you want to make it decimal, go ahead. Okay, but from here, I want you to write this first. Now from here, then either you go to fraction or you go to decimal, either way. But the direct, the makes sense consequence of this notation is this one. That's the next step before you compute that into your calculator. Okay.
I have a question about letter A.
Letter A.
So I think it is wrong because I tried it out just now. I guess I was thinking when I looked at that, I was thinking like 5 over 15 times 5 over 15 times 5 over 15, but I don't think that's right. But I guess why is that? What's the error in that thinking?
Okay, so what you did was 1 minus probability of all blue. That's what you did.
Oh, okay.
Yeah, but 1 minus probability of all blue is the probability of not all blue. That's what you did.
Okay, I didn't even do 1 minus. I guess I was just thinking, 5 out of 15 just times 5 out of 15 times 5 out of 15.
Oh, so if you do 5 over 15 three times,
Yeah.
you are computing the probability of all blue.
Okay.
Yeah. Now the complement of probability of all blue is not all blue.
Mm-hmm.
You know, okay. While here the probability of selecting any blue markers. Now the word any there means at least one.
Okay.
Yeah. Okay.
All right. And actually 63 over 455, it can be reduced. I don't know if you care about that or anything. So for part C, 63 over 455 can be reduced to I think 9 over 65.
9 over 65.
Divide by I think I just used my calculator.
Is it right? Is it multiple? I don't think it's multiple of 3. Is it multiple of 7? Oh yeah, it's multiple of 7.
Yeah.
Yeah, it's multiple of 7. Thank you. I want to erase this. Give me a second. Let me erase this. Yeah, it's multiple of 7. So reduced by 7, that will be 9. Reduced by 7, that will be 65. And then decimal. Okay, that's for part C. Part D is a bigger one. Now, what is part D? Create a probability distribution with number of blue markers selected for a procedure selecting 3 markers without replacement. So let's see. We want to see the number of blue markers selected. Let X be the number of blue markers selected. This X can be 0, 1, 2, 3. You have 5 blue markers and you select 3 from these 15. So you may have no blue markers at all, but the most blue markers you can get is 3, even though you have 5, right? There are 5 blue markers, right? There are 5 blue markers here. But because you select 3 only, then at most you will get 3 blue markers. You won't get 5, okay? Now, what they want us to do here is to first compute or create the probability distribution. So one of the big goal we need to make here is to create this probability distribution. This is X, 0, 1, 2, 3, right? And then you need to find the probabilities, okay? And of course, make sure that they add up to 1, okay? But for us to come up with this, we need to compute the probability for each one of them one by one. Does that make sense? Okay, so let's do so. The first one, what is the probability that X equals to 0? You have 5 blue, okay, and then 10 not blue. The probability that you get no blue means you select 0 from here, and there must be 3 from here. Why 3 from there? Because you are selecting 3 markers, right? If you are selecting 3 markers and they tell you that none of them blue, then the other 3 must be not blue. Okay. Oh, by the way, you may have issue with this. You may have issue with this problem to start with, like Thomas. Who in the world will actually try to work on this kind of markers? What kind of stupid person, you may say? Okay. I believe that in no time of your future life you will do this kind of experiment. Okay, so does it mean that this is useless? No, because I can change this box into, if I want to go to politics, then I can say that into, for example, 7 Democrats, 5 Republican, and 3 independent. Okay, and then in part B, for example, 3 members of these 15 people are selected to be a committee member. The first one will be the chairperson, the second is the secretary, the third one is the treasurer. Or in part C, we want to create a subcommittee of 3 people. What is the probability that one of them independent and 2 of them Democrat? Okay, or I can change this again into some physics problem, which actually arise a lot when we do physics. Yeah, I know you are not in physics major, so you may not worry about that. Okay, or if you do something else, so, I mean, it doesn't have to be political science, right? Okay, it can be, for example, students that you select. Okay, or city council. A lot, a lot. I just use markers and the significance suddenly becomes very, very minimum in your life. But when I change this into political, especially in these 3 weeks we have election, then all of a sudden you see, oh, wow, Thomas, why you make it so political? Well, you want it to be relevant, then I'm trying to make it relevant, right? Okay, but when I try to make it relevant, then suddenly you feel disturbed with it, which I understand, which I understand. Uh, it's quite heated up recently, right? But what I'm trying to say is when I try to make it relevant, then some people may have strong opinion on the example I use. Okay. On the other hand, if I use an example that is as natural as this one, uh, most of you may feel, well, Thomas, what it has to do with my life? You just try to make statistics to be a lot harder. No. The application is actually a lot. Okay. What I teach you here is the procedure in computing the probability, but this is just one example we use. Okay. In the past, I use balls, I use markers, I use a Republican, Democrat, Independent, uh, or maybe like a group of 15 people, for example, 7 of them oppose President Trump, 5 of them support President Trump, and then the other 3 has no opinion. Okay, so it can be like that also, right? It can be like that also. Oh, then not about Trump. Then how about you? Like, there are 15 people. Seven of them likes me. Okay, 7 of them like me. 5 of them they don't like me, and the other 3 they kind of like no opinion at all. It can be he can be okay with me, can be not okay with me. So I may change their mind. If you are the one actually getting into election, right? Instead of you are the one voting, you are the one getting vote. Then what happened? Okay, so let's go on. We want to create a probability distribution of the number of blue markers selected. Probability that x equals to 0 will be, then from blue you choose nothing. Of course, from not blue you have to choose 3. Okay. Over 15 combination 3, that will be 1 times, oh, what is 10 choose 3? 10 choose 3 will be 120, is right? 455. I wonder if it is true. 10 times 9 times 8 over 1. This is 3, this is 4. Yeah, 120. So this will be 120 over 455. Now, don't reduce that yet. And because we will need to continue this frequency probability distribution to find the expectation and standard deviation, later on, you will see you prefer to deal with this in fraction. It's faster. Can I make it decimal, Thomas? Yes, you can. You can make it decimal, but you will have too much compounded error. Okay, too much compounding error. So if I really want to make it into decimal, that will be my like one step before my final answer. Okay, even right now, I can reduce this, but I choose not to do it now. Okay, I will reduce that later, and you will see the reason later. Let's do probability that x equals to 1. What is the probability that when you select 3 markers from this box here, what is the probability you get 1 blue and therefore the other 2 not blue? That will be 5 choose 1 times 10 choose 2 over 15 choose 3. Okay. Now, let me ask you to continue with this. What is the probability to get 2 blue markers? And then what is the probability to get 3 blue markers? Now, leave it in this kind of fraction. You will see the denominator stays 455, and we will leave it like that for now. Okay, but get the rest first. 1, 2, 3, 4. I give you 3 or 4 minutes from here.